Right. Yeah, I'm checking here. Achita. Good morning. Good morning, everyone. Once again, we are back with our second session on probability. So, welcome to Learner's Digital Session. As there were a lot of questions asked yesterday about how about the other subjects, so today I have the answers for that. As yesterday was our first trial class, we wanted to check it and see how the response will be, how the telecast will be, and we are extremely happy. I'm very happy that our founder, Sir Mr. Murali Sir, is really working hard to see that this series is going to continue very well. Not many students logged on. Just wait, please. Let everybody log on. Not many people have logged on. So I should stop? Yes, you should stop and ask whoever has logged on. Tell everybody to log on. We just sent the link. Please share among your friends, and I can see. Yeah, very good morning to all of you. I can see all are now logging in. We'll just take a minute for all of them to log in. I know this is a crucial time where usually the net is always busy, it's overloaded, and I understand that completely. And as you all know, we always have to accommodate the late comers as well. Uh, yes, good morning, good morning. Yeah, I request every student who is logging in, please put up a message in the chat box so that we know the count of the students. As you all know, I can't see you, but definitely I can read you. That's the advantage of this software. And yes, Harika, good morning. Bhavna ma'am also wished me good morning. That's nice. Sanjana, yes, Shrestha. Good morning, all. Okay, not only to me, to all your friends also you want to wish. That's nice. That's a good bonding. Manveet, good morning, ma'am. Yes, good morning, dear. So, yes, Guru means I wish. Okay, I think what is happening, children, I want to just share one small thing. If you have registered, you can write your name and then say good morning or hi. That is also fine so that I know who exactly is mentioning. Like, for example, yeah, Harshit Reddy, I can see. So I know now Harshit is present right now, but certain names I'm not able to figure out. Like I can see Chandra Kalar DCP. Now I don't know exactly who has logged in from that mail, that name. Yes, Sagar Gowda is there. Raju is there. Now see, Raju, I don't know who is the person who has logged in with that. Just write your name so that I can just know who is the person there. I hope I'm clear. Thank you. Yeah, put it up. And also, did you all complete the homework, the assignment that was given to you yesterday on probability? And I hope all of you have completed. And all the CS children know now I'm not there to say that, okay, who have not done the homework. I guess everybody knows what's the next statement I'm going to say. There is some sound issue. Sound, okay. Good morning. Okay, Archit. That's Soundarya. Okay, I got you now. Raju is registered as Soundarya. Fine, very good. Janvi, good morning. Good. Narasimha Murthy, yes. Good morning. Good. Now this is what I was talking because what is happening is we are not able to figure out the names of the student, and that's a good way of wishing so that I know who exactly is there on the other end. Good. So few couple of the things which I wanted to tell about today's session and tomorrow's session. And yesterday's session actually there were a couple of doubts that were asked like about the three right. So we are going to answer that and the common question about how about the different subjects. So let me tell you, Definitely, we are going to start the sessions from tomorrow on the other subjects as well. So, the duration of the class will be longer as we have to accommodate more subjects. So, I want you to have a proper pattern, and we already have put up on the WhatsApp for you for the daily routine. I hope you all are following. Yes, good. Because I feel when we are in such a crucial time of lockdown where we don't know what time we get up, what time we sleep, what time we eat, and I think nowadays we don't even feel hungry. So we need to have a proper routine so that our biological state as well as our mental state is good. Because we are going to face PU second year. By then, this corona will not be there, and nobody will ask us when you go for further showing your marks card of PU second year that I was hit by corona so I could not study. We cannot give excuses in our future. So we have to study. That's the only thing we should keep in mind. And to make our mind ready to study, we should really follow the pattern. So that's the reason why we shared that timetable with you. I really want you to adhere to the timetable, to follow the pattern as much as possible. I know initially few days it might be difficult, but please try to do it. If not, you create your own timetable and follow that. And my sincere request is please put 1 hour of exercise in it. It's really important because whole day we'll be sitting, we will be becoming the potato couch only. So it's really important for all of us to definitely include exercise in our daily routine. So that's a sincere request, and I hope you all will follow. It's a benefit factor for you. So please do that. And coming back to the tomorrow's session is okay. I can see okay many have logged in now. Rakshita, Ananya, Murti, yes. Uh, yeah. I would like to know if the class is clearly audible for all of you so that I can give the further announcements. Yes, very good. Yeah. So coming back to the announcement of how the classes will go tomorrow. Tomorrow we are going to start physics class and it will be delivered by Swaminathan sir and the topic will be moving charges and magnetism. So the class will start by 9 o'clock. So 9 to 10 will be physics session. Then we'll give you a 10 minutes break as we also need a break to adjust the things over here. Then from 10:10 to 11:10 we will have a chemistry class. The concept that we are going to discuss is organic chemistry. Then again we'll give you a 10 minutes break. So 11:20 to 12:20 will be your maths class, the continuation of the probability. We'll see if we are going to complete the chapter by tomorrow or not. We'll see how it is going to happen. And then tomorrow I'll tell you the concepts or the topics that we are going to discuss for day after tomorrow. So I hope I'm clear and I'm going to also message it up in the group as well as in the live chat about what I have told. So tomorrow 9 to 10 is physics, Swaminathan sir, moving charges and magnetism. Then 10:10 to 11:10 is chemistry by Dr. Raghavendra Hegde Katte sir, organic chemistry. Then 11:20 to 12:20 will be maths, probability by Mr. Murali Sir. So these are the instructions which I wanted to give you and I think we can start the session. So let me hand it over to Murali Sir to continue with the probability. Thank you children and pay attention, keep the notes well.
Hello students, Namaste, ಎಲ್ಲರಿಗೂ ನಮಸ್ತೆ ಚೆನ್ನಾಗಿದ್ದೀರಾ Okay, I see that nearly about 70 people have logged now. I request all of you to form your own groups, online groups. Whatever I did yesterday, that is available on YouTube. So you can share that link with your friends so that they can watch that and then they can continue the classes here. So some of you send me a message to discuss the problem number 7, example 7. Definitely I'll do the problem today. So before that, I'll just do quick recap of what we discussed. Yesterday we revised all the basic terminology of probability from the first year. That is, we learned about if you want to solve any problem, In probability, there are three building blocks. First thing is you have to understand what is the random experiment. That is the game. So once you identify this, for every random experiment, there is something called sample space. Then you need to identify events. Then third step is you are going to calculate probability of an event. That is n of e divided by n of s. Then we introduce something called conditional probability. In conditional probability, always there will be two events. A and B or E and F. They always ask like this. What is the probability of A given that B already occurred, already happened? Or probability of B given that A is already happened. So we learned yesterday these two formulas. So if B already happened means what? B becomes the sample space. So that's why it comes in the denominator. Probability of B. And numerator, you want both the events to be happening. B already happened and you want what is the probability that A is happening? Means both you wanted. So that is A intersection B. Same thing you can express using numbers. Number of A intersection B divided by number of B. Similarly, this one P of A denominator, numerator P of A intersection B. N of A intersection B divided by N of A. So this is what we discussed yesterday. I hope all of you are things. Now I will take the example 7. Number 5 also. It seems somebody wanted number 5 also. Oh, okay, fine. First we'll do number 5 then. Before going to number 7, refer to the PDF document which we have shared it. I also request our teachers, if somebody is missing for the class, you may actually remind them, those people. Please. Yeah, fifth question. See, any problem, first we have to understand the given problem. That is nothing but your random experiment or the game. Here what it says, a die is thrown 3 times. That is your random experiment. So, your random experiment is die is thrown 3 times. Can you visualize the sample space? If you start writing this entire sample space, it will be very, very big. You just have to visualize. 6. Can you imagine how much it will come? It is actually 6 into first time 6 possibilities. Second time 6 possibilities. Third time 6 possibilities. It will be n of s is equals to 6 into 6, 36. 36 into 6, 216. This is your n of s. Fine. Now there are two events. Events A and B are defined as below. A, 4 on the third throw. Event A is, I'll write here. Basically, you have to know, you cannot write all of this. If you start writing this, it will be very big list. You just have to visualize the sequence like this, you will get. Okay. Here, 1 comma, like this, it keeps on 1 comma, 1 comma, 2. Next one will be like this 1 comma, 1 comma, 2. Can you guess the next one? It will be 1 comma, 1 comma, 3. So, like that, it goes on. Basically, probably I will draw a tree diagram for you people. It might be more easy. So first time it will be like 1, 2, 3, 4, 5, 6. Then you will get for this 1, 2, 3, 4, 5, 6. Then for this 1, 2, 3, 4, 5, 6. So like this for here also you'll get 6. Here also you'll get 6 like that. So that's why 1, 1, 1, 1, 1, 2, 1, 1, 3, 1, 1, 4, 1, 1, 5, 1, 1, 6. Like that. 1, 2. If I start with this 1, 2, 1, 1, 2, 2. Like that. Can you visualize this? Yes. Once you visualize that one, then it is very easy. Event A is 4 on the third throw. So means you must have 4 on the third throw. That is, if you list down all of those things, what you will get? Event A 1, 1, 4. Right? Next 1, 1, 4. Similarly here 1, 2, 4. Similarly 1, 3, 4. 1, 4, 4. 1, 5, 4. 1, 6, 4. That is one sequence. Yes or no? So 1, 1, 4. 1, 2, 4. 1, 3, 4. 1, 4, 4. 1, 5, 4. 1, 6, 4. I'll just, where is this? 1, 6, 4. I hope you are following. Basically, the last throw, you should have always only 4. You cannot have any other things. Here, if you take this last row, it is 1. Here 2. Here it is 3. But you ignore all of that for event A. So, the favorable outcomes are last one, it should have 4. Now, I have gone like this 1, 1 like this, 1, 2 like this. From 2 also, you can start the same thing. Yes or no? So, in place of 1, I can have here 2. Yes or no? So, here I'll change now. This is 2, 1, 4. Here, yes, 2, 2, 4. So, like that, 2, 6, 4. So, in place of 2 here, now here you see 1, 2, here I have got 3. With 3 also I can start like that. So, like that, 3, with 3 you will get, with 4 you will get, with 5 you will get, with 6 you will get. Yes or no? So, last one will be 6, 6, 4. This is what you need to visualize. Now, if you take a count of this, how many are there? We'll see that later. Similarly, look at the B, event B. What it says, event B? 6 on the first and 5 on the second throw. So, you have to take first one 6, means like this 4, 5, 6. So, all of this you can ignore. First one must be 6. Then 5 on the second throw. So when you do 6, here second throw you may get 1, 2, 3, 4, 5, 6. But you can ignore all of this because they are telling that they are fixing. First one 6, second one 5. Only this you will take. Then for third one it could be anything. That is 1, 2, 3, 4, 5, 6. So if you write that B, event B, I'll write the event B here. I hope it is visible for you. That is, first one is 6, second one is 5. First and second are fixed. Third one can be anything. 6, 5, 1, 6, 5, 2, 6, 5, 3, 6, 5, 4, 6, 5, 5, 6, 5, 6. This is your event B. You need to find the probability of A given that B has already occurred. Can I erase this tree diagram? Here I'll write that. So you have to find out probability of A given that. You have to look for this word given. So before whatever is there, that comes first. Given that, afterwards whatever is there comes second. Probability of A given B. And you know that the formula is n of A intersection B divided by n of B. Now you have got event A and event B. You also need A intersection B. So let me write here A intersection B. Can you guess? Here what it says? Third one must be 4. Here where it is? Only here. 6, 5, 4. Right? only one will come. Yes or no? Because here none of this have got third one, four, only this one. So that comes somewhere here. Okay. Here 6, 1, 4, like that. 6, 2, 4. Somewhere you will get here 6, 5, 4. So that is there in A and also in B. Here also I am not writing all the entire list, because if you start writing all of this, it's a big number. It takes a lot of time. So you don't have to waste your time. So you just have to visualize. So now A instruction B is only one, that is 6, 5, 4. From this you can easily answer, because here only one is there with 4. Here everything must be having 4. So intersection means only one. Now just substituting in the formula. So I'll put it here. Now n of A intersection B. What is n of A intersection B? Means how many elements are there here? Number. A intersection B is the event, that is subset. Number of elements in this. This is how you write. N of A intersection B. How many are there? Only one element. This entire thing is one element or sample point. So it is 1. So that comes in the numerator. Divided by N of B. How many are there in B? How many are there in B? 1, 2, 3, 4, 5, 6. 1 by 6. Textbook, they are using actually the probability formula in place of number. But directly use number of A intersection B by, whenever you know number, that is better to directly use number of A intersection B divided by number of B. Because anyway, probability means you have to divide with sample space, both numerator and denominator. So it gets cancelled anyway. I hope I answered your question. Okay, shall we move on to 7th? This is the very unique problem which I said that yesterday. Entire chapter, this one problem is something unique where you cannot use formula directly. So it is not equally likely outcomes. When you write the sample space, what you get is not equally likely outcomes. So I really want to explain this for all of you. And somebody also sent me a message. My one request to all of you students, when you please send messages, I suggest that you should tell, your name. I'm so and so. Then you please ask, or at the end you please write your name. Then I'll get to know. Otherwise, because I keep getting lot of messages, I don't know from whom I'm receiving this. Sometimes I may call you also. So it's better if you could write your name and introduce yourself and then send me a message. Okay, then I can save also your number with the name so that I'll get to know. Otherwise, I don't know from whom I'm getting messages. But somebody asked me actually to solve example 7. Look, here also, you see, for here I think they have given the tree diagram in the book itself. This is a very good practice for every problem visualizing. Put the diagram. So here it says, consider the experiment of tossing a coin. Coin, all of you know. We toss a coin, okay, we get either head or tails. Then if the coin shows head, toss it again. Suppose if you get head, you have to toss the coin once again. So if you toss once again, what do you get? You may get head or tail. Is it clear? But if it shows tail, then throw a die. Suppose when you toss a coin, I have the props here. Where are my, what it means? Yesterday I told you people. So really what you need is just this stuff to understand it clearly. What they are telling is, first you will toss the coin. So I got actually tail here. If the tail comes, what I should do? I must throw a die now. Suppose if I get the head, I'll toss the coin once again. That is what is happening. Suppose if I get the head, I would have tossed coin once again. Then I get H comma T. But if I get the tail, what I should do? I should toss the die. Then what I will get? I will be getting 1, 2, 3, 4, 5, 6. This is my random experiment now. So in my random experiment, if I write the sample space, Basically, you have to write all the possible paths. The possible paths here are H comma H. First one, H comma T. Then T comma 1, T comma 2, T comma 3, T comma 4, T comma 5, T comma 6. So these are the all sample points in your sample space. Now you clearly observe here. Do you have the equal chance of getting all these elements? No. This is known as not equally likely. Your outcomes, all the outcomes do not have the equally likely chance. It's a common sense because you see here, look at this. Here, what is the probability of getting head and tail first time? It is 1 by 2. Yes or no? Now, imagine that you have got head. Now, you are throwing once again coin. So, you may get head or tail. So, already half is here. For this, it is half. So, if I want to see what is the probability of getting head and head, you have to multiply these two. Half into half. That is 1 by 4. This is probability of getting HH. What about HT? This also 1 by 2. This is also 1 by 2. So 1 by 2 into 1 by 2, it is 1 by 4 for the second part. But here you see, here probability of getting tail is 1 by 2. What is the probability of getting 1 here? It is 1 by 6. Similarly, this is also 1 by 6, 1 by 6, 1 by 6, 1 by 6, 1 by 6. Now, if I want to get the t comma 1, what is the probability of getting t comma 1? This is half into, you have to multiply this, into 1 by 6. That is 1 by 12. 1 by 12. 1 by 12. All will be 1 by 12. 1 by 12. So, these two has got the high probability of occurring compared to all other things. That's why it is not equally likely outcome. You have learnt last year, that is axiomatic approach. Okay. So you will actually, if no, here you have to remember this things. This is 1 by 4, this is 1 by 4, this is 1 by 12, 1 by 12, 1 by 12, etc. Then whenever you want the probability of an event, you just take the summation of all of the individual elements. So let us see how to do that. The question is this. Find the conditional probability of the event that the die shows a number greater than 4, given that there is at least one tail. So there are two events here. So you can call it as event E and event F. Event E, before given that you can put. What is before given that? That is, there is the die shows a number greater than 4. The die shows a number greater than 4. Die shows number greater than 4 means, tell me, die showing number greater than 4 means what? T comma 5 and T comma 6. Die will can show the number 1, 2, 3, 4. Greater than 4 means these two things. So your sample, your elements of this event is T comma 5 comma T comma 6. I hope it is clear. Yes. Now F. Look at this event F. What it says? The die, there is at least one tail. There is at least one tail. These words are very important. Last year I have explained you these words. At least, at most, and exactly. Here it is at least one tail. Can somebody remember what is the meaning of at least one tail? At least one tail means one or more tails. So your number of tails in your outcome should be at least one, or it can be more. So look at these outcomes. Here is there any tail? No. Here, yes, you have got one. Yes or no? Here one, one. So all of these things will come. That is H comma T, because there is one tail here, and also T comma 1, T comma 2, T comma 3, t comma 4, t comma 5, t comma 6. So this is your event F. What you need to find is probability of E given F. That's what it says. Find the conditional probability of the event that the die shows number greater than 4 given that there is at least one tail. Using symbols, this is what it is. Probability of E given F. That is, you can put using numbers only. Number of E, because you will avoid one calculation and one step. Number of E intersection F divided by whatever is there here, denominator. Number of F. Number of F you already know. That is 1, 2, 3, 4, 5, 6, 7. This you know. This is 7. Directly you can put. What you need is E intersection F. What is E intersection F? You want me to write that? Okay, I'll write here. E intersection F. Very simple. Here these two are there here also. You get t comma 5 comma t comma 6. Right? So there are how many elements? Two elements here. N of number you have to put. Number of elements in the E intersection F. That is 2. So 2 divided by 7. That's it. Oh, I'm sorry. I made a mistake. This is what exactly. This is what exactly. We cannot use this formula. I'm sorry. This is what exactly equally likely means. I'm sorry. So we should be doing like this actually. That is probability of E intersection F divided by probability of F. Because now you cannot use the counting. I'm sorry, I was in the same mode as other problems, but I forgot that it is not equally likely. If it is not equally likely, then you cannot go by the numbers. You really have to take the summation of this. If I calculate what is the probability of F, this is actually this how much? 1 by 4. This is 1 by 4. This is all 1 by 12. So probability of F will be, there is 1 by 4 plus 6 times. There are 6. How much? 1 by 12. 1 by 12. That is 6 1 6 twos. So 1 by 4 plus 1 by 2. If I take LCM, it is 4. Here you get 1. You get twos. So that is 3 by 4. 1 by 4 plus 1 by 2. 3 4. That is probability of F. Let us find out probability of E intersection F. This one will be, this is 1 by 12, this is 1 by 12. 1 by 12 plus 1 by 12. That is probability of E intersection F. Sorry. E intersection F 1 by 12 plus 1 by 12. That is nothing but 2 times 1 by 12. That is 1 by 6. Now you substitute here. 3 by 4 divided by 1 by 6. That comes to, this you can divide like 2 twos, 2 threes. So if it goes up, it is 3 by 2 into 3 by 1. That is 9 by, sorry. This is 3 by 2 divided. Sorry. Reverse I should have written. Probability of E intersection F is 1 by 6. I'm sorry. 1 by 6 divided by probability of F. That is 3 by 4. That is 2 threes, 2 twos. So that comes to 1 by 3 into 2 by 3. That is 2 by 9. 2 by 9. Probability of E intersection F. That is this one. 1 by 6 divided by probability of F. That is 3 by 4. Here 2 threes, 2 twos. Then because it is the division, we just have to take the reciprocal of this. Take multiplication and write the reciprocal of this. 2 by 3. You get 2 by 9. Is it clear? I'll just pause for a minute. If anybody still have any questions, Ram Prasad 2 by 9. Yeah, yeah. Yes, yes, yes. Sorry. I took it reverse. Now I corrected it. I'll just pause for a minute and let us take any problems from your exercise. So we have to, this is the only problem with this kind of thing actually. So where you have generally what we do for probability you just count, right, how many elements are there, that number divided by some. Okay, so where you take the summation of all of these things. And there is one rule also, if you remember, summation of all of these elements. Tell me how much you should get for sample space. Summation probability of all sample points in a sample space must be equal to 1. If you want, you can check. You see, this one is 1 by 4, 1 by 4. How much? 1 by 4 plus 1 by 4. That is 2 times 1 by 4. Right? Plus summation of all of this. 6 times 1 by h. So I must multiply 1 by 2 into 1 by 2. In fact, I will be talking about this multiplication theorem after this exercise. Okay, any question, please ask me if you have any doubts in 13.1. Any question? 1, 2, 3, 4. Please, in the message, if you put any question which you wanted, I'll take it.